All right, so we are checking your homework, which was pages 7 and 8 in the packet. So we can start with question number 10, the hardness on the chart. So I did have some questions of what chart they meant. So here is the chart that I meant, the one on page 16 of your reference table. So the softest is graphite or talc at 1. And the hardest would be garnet at 7.5. When I went through, the most common mineral I found on the chart would have been oxygen. And for the record, the second most common was silicon, which you didn't have to do. You only had to include the oxygen one. Quartz is non-metallic, has a hardness of 7. It's colorless and variable, and it's SiO2. Galena is metallic, has a hardness of 2.5. It's silver, and its composition is PBS. Remember, when writing the composition, you need to keep the capitals capital and the lowercase lowercase. Olivine is non-metallic, has a hardness of 6.5. It is green, gray, or brown. And to write the formula, you would have just copied this down. I had to spread mine out. So it's parentheses Fe, Mg2, SiO4. So I ran out of space. Fluorite, it's non-metallic, has a hardness of 4. It's colorless or variable, and that's CaF2. Dolomite is also non-metallic, has a hardness of 3.5, colorless or variable, and it is CaMgCO3 2. Which mineral can scratch glass? Is non-metallic and has a luster, or has non-metallic luster, fracture, and is dark red in color. That is most likely garnet, but since quartz can be colorless or variable, I included that there too. And it fits all the rest. It's non-metallic, it can scratch glass, and it has fracture. And finally, number 18, which mineral can be easily scratched by a fingernail, has cleavage and metallic luster and a black streak? That is graphite. On the back, I'm going to go kind of quick. So those of you who have it done, you'll just be able to check your answers. Those of you who do not have it filled in, I'm not going to go slow enough for you to fill it in. So I'm just going to read the blank ones that you were supposed to fill in. So the first one is KAlSiO38. And that's potassium feldspar. The next one down is non-metallic, yellow amber, sulfur. Then non-metallic, CaF2, and that's fluorite. Then we have PBS, and that's galena. We have non-metallic, 1, white to green, either silver or red, and that's hematite. Then we have that was already filled in, so just selenite gypsum. Then colorless variable, which is fluorite. Metallic, 6.5, FeS2, and that's pyrite. We have non-metallic, 6.5 to 7, and that's garnet. Metallic, 1 to 2, that's silver gray, and that's graphite. We have CaCO3, that's calcite. Fe3O4, that's magnetite. Non-metallic, green, gray, or brown, and that's olivine. Did anybody have any questions on that chart? I know that was a lot. All right, on the bottom then, should be dolomite, amphibole, halite, selenite gypsum, hematite, talc, graphite, quartz, and calcite. Any questions on any of those? For this one that feels greasy, I would have taken one or the other. You did not have to include both. Anybody have any questions there? Okay, you will have a quiz tomorrow. It's going to be about 10 to 15 questions about minerals. You'll need to be able to answer all those things that we just did on that homework. And make sure you can use the reference table, which again was on the homework. Does anybody have any questions about minerals that you can think of right now? All right, so tomorrow we will, about half the class will be for the quiz. The other half, we're gonna start learning about igneous rocks tomorrow, okay? As long as we're talking about what's up. So again, you do have a quiz tomorrow, but you will have homework tonight, and that's going to be on what we're about to learn. It's called the rock cycle. It is on pages 10 and 11. And then again, the quiz tomorrow, and then test corrections. Several of you may want to consider doing test corrections. Remember that you have to not only write out the question, but you have to write out the correct answer and then study and take a similar but different test by this time Friday. No, not Friday, Monday. By the end of the day, Monday is what I meant to say. I don't know why I said what I did. Okie doke. So that's that. Now let's go ahead and get started on the rock cycle. The first thing I want you to do is grab your reference table. Open that up to page 6, please. So you should see this exact chart on your reference table. This is the rock cycle. What do you guys know about cycles? Cycles in general. It's a pattern. I like it. What else could you add to that? They repeat. It's a pattern that can sometimes repeat. It doesn't have to, but it can. Honestly, I think that's probably as good as we need to get. So this is the rock cycle. It's a pattern of how the rocks can repeat themselves. Oh, I meant to do something before this, but now that it's up there, it's up there. Do you guys remember the 3 different kinds of rocks? Igneous, sedimentary, and he doesn't know. Metamorphic. Do you remember anything about those rocks from elementary school? I know my daughters, they both had the same first grade teacher, and they both came home doing a little dance for each one of the rock cycle. Right, rocks. You don't want to dance with me? No? All right. What do you remember about rocks? What do you remember, Teddy? Igneous comes from magma. Perfect. That is the basics of what they learned in first grade. Sedimentary is formed in giant layers. I actually have a pet peeve about that one because a lot of people think that a sedimentary rock itself has to be layered, and it doesn't. Sedimentary rocks come in layers across the earth. So you can look at them and see them layered, but the rock itself doesn't have to be layered. So we'll talk about that later in the year. But you're right. So what was the other part you said about them? Yep, so they get deposited in layers over time. That's good. Well, geez, and that's the same one Jake forgot too.
Face the fact you don't know metamorphic.
So clearly, I think our teachers have done a very huge disservice of metamorphic rocks. If both of you forgot what they are, you forgot how they formed. Does anybody know anything about metamorphic rocks? What does it sound like, metamorphic? It's from heat and pressure, Riley remembers. But where I was going with it, what do you hear with metamorphic? Metamorphosis. Now I know you definitely spent a long time when you were in elementary school learning about metamorphosis. What went through metamorphosis that you taught? I don't think so. Caterpillars. Caterpillars go, and frogs like tadpoles and stuff, they go through metamorphosis. What do? They go through a cycle of changes. Thanks. Well, tell me exactly what they do, Danny. Well, you forgot a few steps, but you're right. It goes from a caterpillar. I think most of the time, do you guys remember the little hungry caterpillar? You remember the little hungry caterpillar in the book? Renee, can you retell us the story? No, first, what is the caterpillar? Page 1. What's on page 1 of the caterpillar book?
I don't know. He's really small.
Not only is he really small, he's a egg. And then he's really small. And then he eats a lot of food. Keep going.
Yeah, then he's all through it, then he like creates a chrysalis.
Then he creates a chrysalis, not a cocoon. Chrysalis,
Are they the same thing?
I don't know. Not my department. Want to know about rocks? Teach you about rocks. And then after the chrysalis,
And then he goes through the change and becomes a butterfly.
he does a beautiful butterfly. Okay, so there we go. So metamorphosis is when a butterfly changes or a caterpillar changes into a beautiful butterfly. What do you think metamorphic rocks do? They change. They are rocks that change. We can relate them back to the butterflies. So you guys know the basics. And that is what I technically, you should have all known that, technically. So you should have known that igneous comes from lava. Sedimentary are pieces that get glued together and form layers across the earth. And that metamorphic rocks are rocks that change because of heat and pressure. Technically, you should have known that. If you forgot, the good and interesting news is this year you don't have to memorize it. So why they make a first grader memorize it and then make a 10th grader not memorize it, I'll never know. But I'm not in charge. So I'm just going to show you how you don't have to memorize it. So here you'll see the rock cycle. The rock cycle, as you can see the three rocks we talked about: sedimentary, metamorphic, igneous. This cycle will tell you what the rock can become, just like the butterfly. Let's write this out for a second. I'm going to switch to here so I can record what I'm writing as well. So I'm going to stop sharing. So you guys do have this in front of you. I'm looking for a piece of paper. I can handle this job. All right. So talking about that butterfly going through some cycles, started as an egg and it went to caterpillar. Hopefully I spelled that right. Oh, and then it went to a chrysalis. A cocoon. I don't know if I'm going to spell that right. And then it went to a butterfly.
I thought it was a chrysalis.
Yeah, there's no way I can spell chrysalis. And I'm not even sure I can spell cocoon, but it's good enough. So we got this. You guys can read this, right? If somebody wrote down egg, arrow, caterpillar, arrow, cocoon, arrow, butterfly, what's that mean to you? Okay, well, somebody else who's not going to skip some steps. Tell me what this means. Carter, what does this mean to you? Starts as an egg. Keep going. Goes to a caterpillar. Goes to a cocoon and then goes to a butterfly. So you can read this. The arrows tell you where it goes, right? Or what it becomes. Starts as an egg and then it becomes a caterpillar. Well, what if I asked you, okay, here's a butterfly. Can you tell me what it used to be? Cocoon. And then here's a cocoon. Can you tell me what it used to be? A caterpillar. Can you tell me what a caterpillar used to be? An egg. The same is true on this reference table. If you read the arrows forward, it'll tell you what it will become. Just like an egg became a caterpillar, that became a cocoon, that became a butterfly. So if you read the arrows forward, it tells you what it will become. What happens if we read it backwards? Tells you what it was, or in other words, how it formed. Let's take a look at igneous. We'll look there first. So everybody look at igneous. If you cannot see mine clearly, look at igneous on yours. So everybody point to igneous on yours. Now I want to know what it was before. So if we read this backwards, everybody read that arrow backwards, follow your finger backwards from igneous. What did it used to be? It used to be magma. So magma, how did it become magma? Jake, I'm kind of in the middle of something. Listen down.
No,
It melted. Good. So you find magma, you read that backwards and you see that it came from melting into magma. This word is solidification. What do you think solidification means?
solid.
Become solid. Yep. Into an igneous rock. Perfect. So did you have to memorize, like Jake had memorized, that igneous came, he said lava. By the way, lava and magma are
I
basic.
said that one.
You said magma?
Yeah.
Okay, sorry. So by the way, if he said lava, that would have been okay because magma and lava are pretty much the same thing. In fact, can you guys squeeze that in? Lava. We'll talk about the difference tomorrow. So he memorized it, but now you don't have to because you'll have this chart in front of you. Igneous rocks come from melting rocks that make lava or magma and they solidify into igneous rocks. Can you tell me then? Let's try it again. Let's point to, what do you want to point to, Renee? Renee wants to, I want to point at sedimentary. I want to look at a rock though. Okay, so everybody point to sedimentary rocks. Gabby, point to sedimentary rocks. And now I want, hey, Braden, point to sedimentary rocks. Put your phone way away. Point to sedimentary rocks. You too, Danny. Ready? We want to read this backwards to figure out where sedimentary rocks come from. When you read sedimentary rock backwards, what do they come from? They come from sediments. And what happens to those sediments to make them a sedimentary rock?
They deposition and burial.
They get deposited. So let's, deposition, just by the way, means deposited. They get buried. So if you want to write that, is there room to write that? Deposited. Buried. Compacted. Cemented together. So those are fancy words that don't mean anything fancy. So if you have room to write that, deposition means deposited, burial means buried, compaction means compacted, and sedimentation means it's cemented together. Yes. So again, if we just read sedimentary rock backwards, it happens when sediments get deposited, buried, compacted, and cemented together. Ooh. Ooh. Do you guys know what sediments are? This we would have learned in 8th grade, but you might have missed it. What is sediment? Riley, you want to give it a whirl? I couldn't hear you. What? Shards of something. What's a shard for the record? Pieces. Sediments are pieces of broken rocks. So all you have to do to figure out the very first question I asked today, which was, what are sedimentary rocks? Read this chart backwards, and it'll tell you how a sedimentary rock formed. And the last one, which none of you remembered except for Riley, when you point to metamorphic rocks and read it backwards, what do you see?
Wait, what are we reading backwards?
Point to metamorphic rocks and read it backwards. Heat and or pressure metamorphism.
I see sin for
What?
I read it backwards.
Oh, don't be a pain in my tushy. Well, okay, so you get the basics. Read it backwards and it'll tell you how they form. But one thing I want to point out. What do you notice? And it's best noticed here at metamorphic.
Igneous has the line across it.
So when I say read it backwards, where did your eyes go? Which arrow did you read backwards? This one? That's the one most of us probably. But look, there's two arrows pointing there. Technically, there's even this third one. What does this mean that there are three arrows that point to metamorphic rock? What do you think, Tyler, that there's three arrows pointing to the metamorphic? What's that tell you? There's three ways to make a metamorphic rock. They all say the same thing. Heat and pressure. This one will go around to make heat and pressure. But notice they can come from an igneous rock that gets heat and pressure. It can come from a sedimentary rock that gets heat and pressure. It can even come from one metamorphic rock that gets more heat and pressure to turn into a different metamorphic rock. So that's true with the metamorphic. It's a little harder to see for sedimentary because it doesn't point, there's only one that point there, but check it out. To sediments, there's the three that turn into sediments. A sedimentary or an igneous rock can get weathered and eroded. Do you guys remember what those words mean? Jake does. Trent, do you remember what weathering and erosion means? Can you give me a basic word for weathering and erosion? Breaks down. By the way, guys, there's a whole chapter on weathering and erosion this year. But the moral of the 8th grade version of weathering and erosion is they break down. So igneous rocks can break down into sediments. A metamorphic rock can break down into sediments. And even one sedimentary rock can break down into sediments. The same is true with melting. A metamorphic rock can melt, an igneous rock can melt, and so can a sedimentary rock. Just like me, rocks are lazy, and they take the quickest path to wherever they're going. So if you are a sedimentary rock trying to become igneous, what path are they going to take? No, melting. Sedimentary rocks are lazy. They're going to take the quickest path there. So they're just going to flat out melt. What they're not going to do is go around the outside. So it doesn't first have to become metamorphic and then igneous. They just take the fastest path wherever they're going. So a metamorphic rock to become sedimentary, how will that happen? Nobody shout. Everybody right now, figure out how what I say? Metamorphic becomes a sedimentary. Figure it out. Raising off your phone. Sam, you think you got it? Remember, rocks are lazy. So they're not going to take a long path there. They're going to take the fastest way possible. Is there a faster way to get from metamorphic to sedimentary? You got it. It will. Uplift, weathering and erosion into sediment, and then do all of this. It skips all of this spots. So you don't have to go around the outside. You take the fastest path there. So they're lazy, like me. And maybe some of you, but I don't want to call you out on that. No, not even a little bit. Lazy joke, yeah. All right, so let's get into our notes, some of the actual notes on this chapter or on this section. So we again are flipping back to page 10. We'll do the notes part and then the homework is afterwards. So it starts at the very top, up by the big banner there that says Rock Cycle what? Oh, I can take care of that. The rock cycle is the continuing change from one rock type to another rock type. Now it's gonna make you do like the rest for homework. But maybe we can do questions 1 through 5 together. Yeah, you like to do that? So question 1, I want you to try doing 1, A, B, and C on your own first. So it just says, describe how each of the following rock types form. Or it says, describe how each of the following rocks form. Can you at least point, go ahead. Yeah, right. I think you got this. What do I have to do on the chart to figure out how they form? Read it backwards. Look at the ones behind it. So let's do sedimentary together. We already did it like twice, but we can do it again. Here's sedimentary. Read it backwards. So what should we write for how a sedimentary rock forms? Okay, so I'm gonna, okay, that works. Sediments. Get deposited. Buried. Oh, shoot. Compacted together. Sorry, I did not, I should have had 2 lines there. Somebody new, tell me what I should write for igneous. Kelvin, I haven't heard much from you. What should I write for how igneous rock forms? Solidification of what? Magma. So again, just take igneous. Yes, the solidification, but I want of what? I'm actually going to include melting. So I'm going to say melting and solidification of magma. Nate, I haven't heard from you yet today either. What should I write for metamorphic? Form from? Ooh. Just sedimentary rocks? And? So check out this arrow too. The key here, yes, it can come from sedimentary. Yes, it can come from igneous, but check out this one that goes around. So metamorphic can even do it. So how I describe it is heat and pressure from any other rock. Question 2 says, name the rock that comes directly from other rocks. What do I mean directly from other rocks? Straight from another rock. For example, if I said, go directly to the office. What do I mean, Sean, when I say go directly to the office? Go to the office and don't do it what? Don't do what if I tell you to go directly to the office? Don't go anywhere else. Don't make a pit stop. You go directly to the office. You go right there. You don't stop at your locker. You don't stop at the bathroom. You don't run out the door and run home. You go directly to the office. Which rock type, metamorphic, sedimentary, or igneous, comes directly from other rocks without making another stop? What do you think, guys? Everybody look at the chart. Which one doesn't make a pit stop? Nate, you got it? Metamorphic. Sedimentary, straight to metamorphic. I'm guessing, are you looking? Oh, for me? Okay. So that one is metamorphic. See if you guys can figure out the rest of them. Because like I said, the rest is going to be homework anyway. I think I'm just going to let you go for the rest. It was homework anyway. We already did 3 of them together. So for the rest of the period, which is only about 5 minutes, I want you finishing page 10 and doing page 11. Careful with the wording. Some of them are worded mean. Meaning somebody wrote them and was trying to be a mean, big, poopy pants. So again, your homework is pages 10 and 11, and you have a quiz tomorrow.